Okay, everybody, welcome back. This is example 8.3 on our potential energy and conservation of energy chapter. And we just talked about the fact that the work done by gravity is represented by a negative change in potential energy. That is U initial minus U final. And now usually a change means final minus initial, but since negative change, it's going to be initial minus final. But in this problem right here, we're talking about somebody who's doing work against gravity. The reason you climb mountains and stay fit and stuff is because you need to have the energy in your body to work against gravity and get yourself up to the top of the mountain right there. So this mountain climber, this 82 kilogram mountain climber, is working against gravity to get from here to here. Now this is going to be an exercise in calculating the amount of change in gravitational potential energy from this point here to this point right here. And we're going to do that using two different reference points. Okay? What I mean by that is this. I'm going to shrink this down a little bit. Center that right there. Okay. This person is going from here to here, and they are climbing upwards 100 meters. All right? But in part A, it's saying, okay, well, let U equals 0, that is the potential energy equals 0, be at sea level. Okay, well, we know how high Pike's Peak is because it tells us right here. At the very top is 4301. So the initial potential energy, U initial right here, equals, well, how do you find potential energy at any one point? We just described in the last section that potential energy, all right at the top right here, due to gravity equals mg y, or you might say mgh. How high up are they? Okay, so if we call sea level, which is way, way, way down here, you know, thousands of meters below, 0, then that means his initial position is 4,000. What's that? 301. So it'd be 4,201 meters, right? He's at 201 right now. He goes up another 100 meters. He'll be at the very tip top at 301. So let's just write his mgh right now initially. His mass is 82 kilograms. Okay, 82 kilograms times 9.81, right? Mg times his height. His height initially at this point is 4,201 meters. 201 meters. That's not a very good 01, is it? Erase my 2 as well. 201. Okay. And his final potential energy, I'm going to write it at the top right here, U final, is his mass times gravity times his final position right there at the top. So he's going from here, well, he's going from the lower up to here. All right, so his gravitational potential energy is going to be his mass, 82 kilograms times 9.81, times his now height at the very top of Pike's Peak, and that is 4,301, 4,301 meters. And that's his final potential energy. So the question is, what is the change in gravitational potential energy? So the change in U. Well, we know that gravity causes a negative change in U, or potential energy, but if you're working against gravity, it's going to be an actual positive change or a regular change, and change is always going to be U final minus U initial. Okay, so what's that going to be? That's going to be, well, we can probably do our calculations right here. Let's do them up there, and then we'll just plug them in at the bottom. All right, our U initial is going to be 82 times 9.81 times 4201. 82 times 9.81 times 30. I'm getting all messed up here. Give me a second. I was having calculator problems. Okay, I got a pretty big number right here. 3.38. 3.38 times 10 to the 6th joules he has of energy right here at this initial position. It's a lot of energy. All right, so if you've got a big number, you're probably thinking, oh, wow, big number, that must not be right. It actually is right. He's got a lot of energy. He's got a lot of potential to fall down that mountain. And if the mountain were any steeper, it would be even more dangerous because he could fall a further distance and probably wind up losing his life. So that's our initial energy right there. How much energy does he have finally at the very tip top? I get that he has 3.46 times 10 to the 6th joules of energy right there, which is an even greater amount. All right, so we're going to just subtract these. 3.46 times 10 to the 6th joules and minus 3.38 times 10 to the 6th joules. So what's our total change in gravitational potential energy between here and here? I get that he has a change of energy, a change in potential energy of 8.0 times 10 to the 4th joules. So what's that, 80,000 joules just from here to here. That's 100 meters, and even so, that's a big change in potential energy. All right. So even if you fell down 100 meters from there to there, you probably wouldn't live to survive the experience. All right. It's a lot of energy right there. You don't want imparted to your body all at once. So we did this problem assuming that base level was 0 was way down here, and this height was 4201, and this height was 4301. Okay. Part B, this is part A right there. Part B says, all right, what if we call this 0 and this some level below 0 right there? Are we going to get any different of an answer? Well, we're going to find out in just a second. So for part B, I'm going to do it on the right-hand side right here. We have our initial position. I'm going to do it kind of on this side of the mountain right there. He's starting there, and then he's ending up here, right here. So his initial position, U initial, is actually, let's start at the top right here. His final position, if we call the top of the peak 0, if that's the top of the peak right there, so our MGH, well, if that height, if we call that 0, and that's just going to be 0, which means everything is going to be 0. Which means then that if we call this level 0 and he starts down here, he must be starting at a negative position right there. All right, so his initial position is going to be his mass, so that's 82 times 9.81, that's G, right? Times, what is his position? Well, if that's 0 and he's 100 meters below the position, then that must mean that he is at negative 100 meters. Negative 100 meters right there. Well, this should be some pretty easy math to find this difference right here. But let's find what his gravitational potential energy is right here at 100 meters below 0 level. And I get that right here he has potential energy of negative 8.0 times 10 to the 4th joules, which should sound pretty familiar to you. All right, but that's the initial potential energy. Here's the final right here. Let's just find our change in gravitational potential energy because he's working against gravity to get him up there. So it's going to be U final minus U initial equals, so 0 minus negative 8.0 times 10 to the 4th joules. Well, that's just going to be regular old 8.0 times 10 to the 4th joules. So the change in potential energy from here to here is the same regardless of what your coordinate system says is base level. Remember in part A we said let's let base level be all the way down to the ground right here. In part B we said let base level be at the top. It doesn't matter. You are working against gravity, and so you are increasing your potential energy the same amount regardless of where you start your coordinate system. That's why it's nice that we define gravitational potential energy is simply a change in your potential energies. It's simply the difference in MGH of your initial and MGH of your final. All right, that's a good example that shows that we can put our coordinate system wherever we want. That's going to be it for this segment, this example. I'll see you on the next one.